Good morning, students. Yes, chapter 5, Magnetism and Matter. Yes, we are about to complete this chapter. Yes, we have completed our theory. Now we will see some remaining questions. Exercise 5.22. What is question? See, electron beam having kinetic energy 18 kilo electron is initially moving in horizontal direction, is subjected to a magnetic field of 0.4 Gauss, normal to it. Estimate the up or down deflection of the electron over a distance of 30 centimeter. Over a distance of 30 centimeter. See here. First of all, electron beam having energy 18 kilo electrovolt. Okay. So see, kinetic energy of electron K is equal to 18 kilo electron. Kinetic energy which is half mv square is equal to 18 10 raised to 3. 1 electron volt means 1.6 into 10 raised to minus 19. Okay. Yes. First of all, we will find what is speed of electron beam. Okay. So yes, V is equal to under root it is 2 into 18 into 10 raised to 3 into 1.6 into 10 raised to minus 19 m in division. So yes, it will be 9.1 into 10 raised to minus 31. And if you calculate this, you will get value of V. You will get value of V to be, it is 0.795 into 10 raised to 8 meter per second. Okay. So first of all, we have to find what is speed of electron. Okay. Now, is subjected to B is equal to 0.4 Gauss, normal to it. Normal to it means what? Let magnetic field is perpendicular inside. Let magnetic field is perpendicular inside. Like this. Okay. So yes, electron beam is initially moving in horizontal direction. Okay, electron beam is initially moving in horizontal direction. We know that when electron beam moves in horizontal direction and it enters magnetic field normally, if it enters magnetic field normally, it will perform circular motion. It will perform circular motion. Yes or no? And yes, up or down. So yes, I have assumed magnetic field perpendicular inside. Velocity is in this direction. Magnetic field inside, so force is acting in upward direction. So here, this electron will be deflected in upward direction. This electron will be deflected in upward direction. Clear about this? Now, what is question? See, normal way, estimate the up or down deflection of the electron over a distance of 30 centimeter. Over a distance of 30 centimeter means from here to here. Over 30 centimeter distance. Is equal to over 30 centimeter distance. By how much amount it is deflected? By how much amount it is deflected? It is deflected. Clear? So yes, you have to find this deflection. You have to find this deflection. Okay, how much it is deflected? How much x it is deflected? You understand what is question? Yes. When electron enters magnetic field normally, it will perform circular motion. It is deflected, deflected, deflected. You have to find deflection over a distance of 30 centimeter. Means 0.3 meter. 0.3 meter. Clear about this? How to find this displacement? As it is performing circular motion, having some center? Yes or no? Yes. Obviously, it is nothing but radius r. Yes or no? It is nothing but radius r. It's radius r. Okay, it is also radius r. Yes, it is also radius r. If I draw one line like this, okay, yes, I have to find this displacement, which I have to find this distance. I have to find this distance. This total distance is r, but I have to find only this distance, x. Clear about this? Okay, it is r radius, it is also r radius. Yes, I am assuming this angle theta. I am assuming this angle theta. Clear about this? Then yes, it is r, it is angle theta, it is its adjacent side. It is its adjacent side. So in this triangle, if I am giving some names, it is O, P, and here it is Q. Then in triangle OPQ, in triangle OPQ, okay, if I am taking cos theta, then cos theta is equal to, cos theta means adjacent side, OP upon hypotenuse, that is nothing but OQ. OP upon OQ, it is nothing but R. So OP is equal to, it is R cos theta. OP is equal to R cos theta. So this distance is R cos theta. I have to find this distance. What is deflection? So deflection x is equal to, see from figure, you have to find this deflection x is equal to, this total distance is R minus this distance OP is R cos theta. It is R cos theta. Clear about this? So yes, it is R 1 minus cos theta. But what is R? Capital R, that is radius of circular path. How to find radius of circular path? Yes, we know. This charge is performing circular motion. For that circular motion required centripetal force. Okay, required centripetal force is provided by magnetic force. Okay, so required centripetal force is provided by magnetic force, which is m v square upon r is equal to, here it is q vb, but here we have to be declared on, so it is e vb. Clear about this? So yes, v cut r is equal to, it is mv upon qb. Mass of electron 9.1 into 10 raised to minus 31. V, what is value of V? Yes, here it is. It is 0.795 into 10 raised to 8 divided by Q, that is charge of electron, means this E. It is 1.6 into 10 raised to minus 19, and magnetic field is 0.4 Gauss, so it is 10 raised to minus 4 Tesla. 0.4 into 10 raised to minus 4 Tesla. Okay, and if you find this, calculate this, you will get value of R to be 11.3. You will get value of R is equal to 11.3. Clear about this? Okay, now yes, you know what is value of R. You have to find what is deflection. So yes, deflection. X is equal to R 1 minus cos theta. R 1 minus cos theta. Cos theta, yes, what is value of cos theta? Cos theta is equal to, it is this OP. It is this OP upon this distance. But how to find this? See, here it is. This distance is 0.3. This distance is 0.3, and this R is equal to, it is 11.3. Yes or no? So yes, with the help of Pythagoras, you can easily find this distance. Yes or no? You can easily find this distance. Okay, or you can find what is value of theta. From this triangle. Find value of theta because you are given opposite side and hypotenuse. So first of all, find sin theta. Sin theta is equal to, it is E upon R. You will get value of theta. That value of theta will be okay, given. And then put value of theta in this case. You will get your deflection. Clear? So yes, there are two ways to find this deflection. First, x is equal to R 1 minus cos theta. How to find? 11.3. So you can easily find this distance. Yes or no? Yes, you can easily find this distance with the help of Pythagoras theorem. Then subtract this distance from radius R. You can find it. Second method is, from this triangle, first of all find value of theta, that is angle, and then put value of angle in this equation. Okay, whatever method you like, you can easily find. Okay, here how to find x? X is equal to R minus OP. OP you can find with the help of Pythagoras. Clear about this? So yes, it is one simple question which is based on motion of charged particle in uniform magnetic field. Okay. See, one question, exercise 5.9. A circular coil having number of turns 16 radius r is equal to 10 centimeter, carrying current I is equal to 0.75 ampere, is placed such that plane is normal to magnetic field 5 into 10 to minus 2 Tesla. If, yes, it is placed normal to field means it makes angle 0, means it is an equilibrium condition. So if from equilibrium condition, if it is turned about its main position, about its own position and released, then obviously it will perform simple harmonic motion. With frequency f is equal to 2 seconds, you have to find what is moment of inertia. Yes, we know what is equation of frequency. F is equal to 1 upon 2 pi under root mb upon I. But first of all, you have to find what is value of m. M is equal to it is NIA is equal to it is NI. Circular coil means A is equal to it is pi r square. So first of all, you have to find what is value of m with this already. It is 0.1 meter. Okay. Then yes, as you have to find moment of inertia that I am denoting by small I. Then yes, take square on both sides. F square is equal to 1 upon 4 pi square mb upon I. Then you have to find moment of inertia, make it such that I is equal to it is 1 upon 4 pi square, it is mb upon F square. Simple? Yes. And you will find from this B, it is given 4 pi, that is 4 pi. F you are given, so you can easily find what is moment of inertia. Okay. Next one is phi, that is deep angle is 22 degree. Horizontal component of Earth's magnetic field, it is 0.35 Gauss, and D is equal to, you have to find question mark. Exercise 5.11, again phi, that is deep angle is given, that is 60 degree. Horizontal component of magnetic field of Earth, that is 0.16 G. You have to find magnetic field. Yes, we know one relation, that is BH is equal to D cos phi. So B is equal to, it is BH upon cos phi. B is equal to, it is BH upon cos phi. Clear about this? So yes, in these two questions you have to use this equation. Last one is, you are given a Roland ring. Okay, Roland ring means nothing but one type of toroid. Okay, having mean radius r is equal to 15 centimeter and numbers of turns having n is equal to 3500. Yes, what is different? This core of this ring is made up of a material having relative permeability mu r is equal to 800. You have to find what is magnetic field produced in the core of Roland ring. If current flowing from each and every turn is 1.2 ampere. It is nothing but toroid. Again, it is nothing but toroid. We know what is equation of magnetic field for toroid. Yes, B is equal to, it is mu 0 Ni. No, here we will not use this equation. Why? Mu 0 is used when medium is vacuum or air. Okay, here as we are given different medium, you have to use B is equal to, it is mu and I. It is mu and I. Clear about this? Yes. Here this core is of another magnetic material. So B is equal to, it is mu and I. So B is equal to mu. How to write mu? Yes, you know. It is mu 0 mu I. N, that is numbers of turns per unit length. So it is capital N per unit length. That is 2 pi r. Here it is I. Okay, so B is equal to mu 0 mu r and 2 pi r I. Mu 0 4 pi into 10 to minus 7, mu r 800, n, yes, n 3500, I 1.2, 2 pi, that is 2 pi, and r is 15 centimeter, means 0.15 meter. You have to convert in meter, 0.15 meter. Clear? Yes, you have calculator, you can easily find this value in Tesla. Okay, so yes, some easy questions. Okay, so yes, with this we are at the end of this chapter 5, that is magnetism and matter. Okay, watch videos regularly, make your notes regularly, and yes, if you have any doubts, then try to solve your doubts regularly. Plus, like, share and comment regularly. next question, exercise 5.20. A compass needle is placed in horizontal plane, placed at center of circular coil of 30 turns and radius 12 cm. The coil is in vertical plane, making an angle of 45 degree with magnetic meridian. I is equal to 0.35 ampere, that is from circular coil. Needle in this situation is aligned in west-east direction. West-east direction. Okay. So yes, first question is we have to find what is horizontal component of Earth's magnetic field. If current is reversed and coil is rotated by 90 degree in anti-clockwise direction looking from above, then predict the direction of needle. See first question we will see. Compass needle is placed in horizontal plane at center of circular coil. So first of all, for circular coil, yes, three data is given. First, numbers of turns, n is equal to 30. Radius, r is equal to 12 centimeter. Okay, and current I is equal to 0.35 ampere. Okay, now see what is given. Placed at center of circular coil of 30 turns and radius 12 cm. The coil is in vertical plane, making an angle of 45 with magnetic meridian. Suppose it is magnetic meridian. Suppose it is magnetic meridian. Okay, so coil is placed such that it makes angle 45 degree with A. The plane of coil makes angle, it is plane of coil, that is making angle 45 degree. Clear about this? Clear about this? Now let current going from this coil, it is in this direction. It is in this direction. Okay. For example, current flowing from this coil, it is in this direction. So yes, due to that magnetic field, it is in this direction. Yes or no? On its axis. On its axis. So due to this current carrying loop, magnetic field produced B, it is in this direction. It is in this direction. Clear about this? We know that at each and every point, horizontal component of Earth is from geographical south towards geographical north. Means horizontal component, it is in this direction. It is BH. It is BH. Clear about this? Okay. So yes, due to this two magnetic field, you are given a magnetic needle which is placed at center. Magnetic needle which is placed at center of coil is in west-east direction. Is in west-east direction like this. Okay, magnetic field it is in west-east direction like this. Clear about this? Clear about it? So yes, it is nothing but needle. It is nothing but needle. Needle means resultant magnetic field is in this direction. Resultant magnetic field is in this direction. Clear about this? Now say, as this angle is 45, okay, this magnetic field due to this is current carrying ring is perpendicular to it like this. So yes, obviously, if this angle is 45, this angle it will become 45. This angle will become 45. Okay, it is BH. Okay, horizontal direction, it is like this, so it will become angle 90. Okay, so yes, we have it is B, it is BH, and this angle is 45. It is B, it is BH, and this angle is 45. So yes, we can apply 45. BH is its opposite side, and it is hypotenuse. So which trigonometric function you have to consider? Yes, sine 45. That is sine 45 is equal to opposite side upon hypotenuse. So BH is equal to it is B sine 45. BH is equal to it is B sine 45. Where what is B? B is magnetic field produced due to this circular coil. So BH is equal to this mu 0 Ni upon 2r sine 45. Sine 45. You know what is value of mu 0? You know what is value of n? You know what is value of I, r, sine 45. You put value and calculate your answer. Clear about this? So yes, again, this magnetic meridian, coil is placed like this. Coil is placed like this. Due to coil, magnetic field on axis is in this direction. Horizontal component is from towards, it is towards south to north. Okay, so yes, resultant magnetic field, you to a river, needle aligns in direction west to east. It is west to east. Yes or no? Yes. So yes, here is magnetic field due to circular coil. It is magnetic field due to earth, and needle aligns in this direction means it is resultant magnetic field. Okay. This angle you are given 45 between magnetic meridian and plane of coil. So this angle obviously it will become 45. Yes or no? So yes, yes, yes. This B, it is BH, and this angle is 45. So take sine 45 is equal to this BH upon B. So BH is equal to B sine 45, and you can calculate your answer. Clear about this? Okay. Next question is current is reversed and coil is rotated by 90 degree. If current is reversed in the coil and coil is rotated by 90 degree in anti-clockwise direction from above, then predict the direction of needle. Direction of needle reverses, because direction of magnetic field due to this reverses. Okay, so yes, as direction of current reverses, okay, direction of needle also reverses. That is from east to west. Clear about this? So yes, it is one question of chapter 5, and yes, with this all I think illustrations and exercise over. Yes, remaining questions are theoretical, so you can easily find out. Okay, so yes, with this we can say it is end of chapter 5. Now we will see some MCQs, some questions, and then after we will start our new chapter.